Hey Math 1, I've got a little addition to the videos that I put on compound inequalities. The previous one had a mistake on number 5. I mean, it was just a little, I think I added a negative randomly, but then I forgot to do number 6 altogether. So I thought, I don't know if I have the time to go through the whole 1 through 6 again, but I can just make a little video where 5 and 6, you've got the right solution. So we're just going to do that right now. All right, so when you get a compound inequality situation where they're connected at the beginning like this, the idea is I'm going to look at this as two inequalities. 4 is less than 5 minus 3x is a completely legitimate inequality. It can stand alone, and that's exactly what we're going to do. We're going to say this one stands alone. 4 is less than 5 minus 3x. This also is a standalone inequality. We know that 5 minus 3x has to be less than 15, so we can separate it. Now, because they're connected, it implies an and situation. So connected inequalities like these, are always and statements. So connected, and I mean like there's multiple inequality symbols on one line here. Connected inequalities are always and. Never or. And hopefully you guys watched the videos on what it means to be and versus or mathematically. If you didn't, I don't know if this makes much of a difference. So go back and watch those videos. So these are just two simple inequalities to solve now. Subtract 5, subtract 5. You've got negative 1 is less than negative 3x. Same move over here. Subtract 5, subtract 5. You got negative 3x is less than 10. Divide both sides here by negative 3. That flips the direction of the inequality symbol. You got 1/3 now is greater than x. And then over here, you divide both sides by negative 3. That also flips the inequality symbol. X now is greater than 3, 6, 9. 3 goes into 10 3 times. And there's 1 left over, so in 1/3. A positive divided by a negative is a negative value. So there's the solution. 1/3 is greater than x, and x is greater than negative 3 and 1/3. But probably I want to rewrite this as x is less than 1/3. When your x is on the left, it points you in the right direction. And keep in mind that if it's connected at the beginning, then usually you can write a connected inequality statement to represent a solution. So that connected inequality is saying, let's put x in the middle, all right? It's less than 1/3, but from x's perspective, okay, x is greater than negative 3 and 1/3. So recognize that this is a legitimate way of writing your solution, as well as this is a legitimate way of writing your solution. If you recall, the graph for these are generally shade what's between. And that's exactly what we're going to do here. 1/3 would be about right here, open circle. Looks like we're less than, so it's going this way. X is greater than negative 3 1/3, so it's about here. It's going this way. You'd shade between. Because and means what they share. And means the intersection of the two solution sets. Okay, now the only difference is on number 6, The only difference from number 5 to number 6 is that you have x's in all 3 parts of the inequality. And for some reason, that just throws students off. But here's the idea. This inequality can stand alone. All right, so all I'm doing is I'm going up until the second inequality symbol, and I'm saying forget everything else. 2x minus 1 is less than 7x. And then you ignore everything left of the first inequality. 7x is less than 3 plus 4x. If it's connected at the beginning, it is forced into an and situation, and then you just solve the two. So go ahead and pause the video and try to solve those on your own. All right, let's see if you're correct. I'm going to get the x's together over here. You got negative 1 is less than 5x. Divide both sides by 5. Now, the bottom is not negative, so I'm not going to flip that symbol. It's negative 1/5 is less than x. Which I'm going to rewrite this so that x is on the left. X, from x's perspective, x is greater than negative 1/5. For the second one, I'm going to subtract 4x from both sides. You get 3x is less than 3. Divide by 3. You get x is less than 1. So as a connected statement, this would be x in the middle, it's less than 1, but it's greater than negative 1/5. And then for our graph, we get an open circle at 1. Less than means go left. At negative 1/5, we have an open circle. It's about right there. And it's everything bigger than, or everything to the right. And means what they share. These two solution sets will keep going forever, but they only share what's in between. There you go. All right, so again, my apologies for the first video just being, the error on number 5 and then totally forgetting number 6. Check this out, and I think you'll have a pretty good sense of what connected inequalities look like, how to solve them, and how to graph them. All right, thanks for watching.